Hey, hi, welcome to the random topic series. So today we are going to discuss about I2C communication protocol. I2C is commonly called as, inter-integrated circuits, which was developed by Philips Semiconductors for the data transfer or basically the communication between a central processor and the different ICs that are present on the same circuit board. Few of the important features of the I2C communication interface of the protocol. So it is two-wire interface, and it is actually very easy to use in terms of adaptability or in terms of integration. It follows the 7-bit addressing mechanism through which we can actually communicate with the each device that is present on the I2C bus line. In terms of scalability, say if you want to integrate a new device into the I2C bus network, it is way simple because you just have to communicate with the SCL and SDL lines. And it is very easy for the data validation considering it's very simple communication protocol. Now, when we consider the use case, it is used in different applications, like say when a microcontroller has to communicate with EEPROM chip, or say in terms of like the IoT devices, or it can be a display like say GC9A01 display modules, or it can be SSD1306. There are multiple displays available in the market, and also of course different sensors like say accelerometer sensor, temperature sensor, humidity sensor. There are a lot of sensors available in market. So the next thing that we will be discussing on is with respect to the physical configuration of a I2C bus or a I2C bus line. Like say, so the I2C bus consists of two different lines. So the bus is nothing but an interfacing wires. So that is SDA and SCL. SDA stands for serial data line and SCL stands for serial clock line. The data to be transferred is sent through the SDA line here, and this is particularly synchronized with the clock line from the clock line or the clock signal coming from SCL. So all of these devices that are present here are connected to the same SDA and SCL line. The same thing which I had mentioned. When it comes to scalability, it is pretty easy to scale, considering multiple devices in one particular circuit board. So the devices connected on the I2C line, are categorized into two major parts. One is a master and one is slave. So only one master can be active at any time, during a I2C operation. It controls the SCL line and decides what operation needs to be done on the SDA line. All the devices responds to the instruction that is sent by master, and for differentiating between multiple slave devices, master uses this 7-bit addressing mechanism to differentiate between each slave device that is present on the I2C network. The master wants to transfer any data to a specific device on the I2C network, it basically assigns the slave's address in the SDA line, and this is how the slave understands that the master is communicating with me. So this is in general how the I2C communication protocol works. Definitely stay tuned for the next video, because there is an important topic that is coming up in the next video, which basically tells how data transfer happens between the master and slave in detail. So stay tuned for more videos. Have a good day, guys. Bye. Take care.